Alright, welcome back ladies and gentlemen. We're talking about 2.2 day 1 here with slope or rate of change. And we're going to be calculating the slope, also known as rate of change, of a line based on the graph of the line or based on 2 points on the line. Okay, now here we can see we've got a graph of people with health insurance in millions, and that's going to be based on the year. Alright, now the question I got there is how many more people are there with health insurance each year? Alright, well, okay, taking a look at this, and what you might do is you might look at 1989 right here and see that there's 212 million people, and then you look at 1990 and come up here, and at this point we're looking over here at 214 people. And pretty quickly the difference between 214 and 212 is 2 million. If you wanted to check yourself a little bit further, you can come over here to 1991 and then you can look over here at 216 million, so again it went up by 2 million. So we can continue that, but I'm sure I would bore you to tears with that, so basically here's our answer. How many more are there each year? There are 2 million people more with health insurance each year. Alright, so that's kind of good. Alright, now that number we just came up with, the 2 million, is the rate of change in the number of people with health insurance per year. Notice each year we had 2 million more people with health insurance, and that trend continued. And mathematicians in a situation like this frequently use the word slope as a synonym for rate of change. Okay, now please do, as we're talking about various problems, pay attention to rate of change words such as per or each. Okay, if those words are being used, you are likely talking about that word I just said, slope. And quite honestly, I will use the word slope a lot more often than rate of change just because, hey, it's shorter, it's easier to say. And it's just simple as that. Alright, so for example, although the slope stuff does come up in real life, if you've got a job and you get paid hourly, then you might make $12, and I'm sure I don't have to tell you this, probably a lot of people are thinking that already, $12 per hour. Okay, as soon as I see per, okay, that $12 is the rate of change for the paycheck you would get for that job. So you make an additional $12 for each hour you work. You work 1 hour, you get 12, you work 2 hours, you get 24, etc. Alright, now sometimes we're going to have a graph and we're going to want to know the slope of the line on that graph. And so, well, there's a way to do it. Alright, now the slope, which we're going to abbreviate using m. If you want to know why, ask me in class, I'll be happy to tell you. But we're going to use an m for slope. And that's the ratio of the rise of the line divided by the run of the line. Alright, so basically what we're going to do is pick any 2 points on the line, and we're going to find out the rise, which is basically how high it goes from one point to another, and then the run, how far it goes left to right. Okay, so for example, this line right here, again, I got 3 points on the line highlighted, but I'll just take any 2 I like, and I'll just take these 2 kind of left and then middle, and well, starting at this point right here, I want to find out how far I rise. So if I just kind of go right here, I went 2 units up, so it's a positive 2, so in our case, I've got a 2 as my numerator, and then my run is how far from there I go to the side. Now don't count where I am as 1. I see people do that sometimes, it messes them up, of course. Okay, so I'm starting right here, then I've gone over 1, 2, 3 units to the right. Alright, so that gives me an m, a slope of 2/3 for this particular case. Alright, now you might be saying, hey, what if you went from the other one? Well, notice if I start right here, notice I'm still going up 2, and I'm still going over 3 to the side. That's still a 2, and that's still a 3, so it's irrelevant which 2 you start from. You might be crazy right now and be thinking, hey, what if I go from this one on the far left to the one on the far right? Does that change things? Well, let's start here. So I'm going to count 1, 2, 3, 4 units up. And then from here I'm going to go 1, 2, 3, 4, 5, 6 units to the side, so there's a 6. Hey, those are different numbers. So, hey, maybe 4, 6. But, hey, wait a minute, I can reduce that. So basically, if you do have numbers that are reducible, please do that. Now notice 4 over 6, if I divide both of those by 2, does give me 2/3 again. So, the moral of the story is pick any 2 points you like. You'll get the same answer, assuming you do everything else right. Alright, so slope is just a number we can assign a line in order to talk about its steepness. Alright, so that's all it is when we're talking about slope. We're just saying, hey, how steep is this line? Now consider the 2 lines pictured here. They are definitely steeper than the previous line, and the second is steeper than the first. But it's important to be able to compare the steepness more precisely, so mathematicians do that with a number, and again we call that number slope. Alright, now here's those two lines from the last slide, pictured again, and so let's just find out the slope and see how much steeper one is than the other. Alright, so again, I'm going to use M for slope. If you don't like M, then feel free to write the whole word out, but here we go. Okay, and again, I'm just going to pick any of these 2 points. I'm going to pick this one right here because it's in such a nice spot, and I'll pick this one to go to. So here I'm going to go up, like to up 2, and then from here to here, I know it's a little bit tight in here, but you can see hopefully that that's a 1. So my slope is 2 over 1. Okay, now 99 times out of 100, when you've got 2 over 1, you probably don't still think of that as a fraction. So I would prefer, if you have 2 over 1, that you just turn it into 2. No, we won't consider it wrong if we leave it as 2 over 1, but it's a heck of a lot nicer to say 2. Alright, that being said, let's move on to the second guy. Again, pick any 2 points you like. In this case, I'll go from the middle to the right, I suppose. And again, just a matter of counting. So I'm going to count all the way up to here. That was counting up 3. And then again, from here over to the side, coincidentally is also a 1. So in this case, my slope, I went up 3, and I went to the side 1. And likewise, if it's 3 over 1, well, that's just 3. Now let's move on to a couple other ones. And you can see here that these guys, at least to my eye, I look at these and I think they go downhill, as opposed to the previous examples. They've all been kind of going uphill as you go from left to right across the graph. Okay, so again, slope is still going to be the same basic idea. I just want to know how steep this is, but here we go. So I'm going to start at this point and go to this point, and again, it's just a matter of counting. So here, I'm coming this way. Now notice what happened though. I went from here down. So even though this is a 3, since I went down, I want to think of that as a negative 3. And then as I go across, notice I'm still going to the right, so that's still in a positive direction, so I'm going to call that positive 4. So my slope in this case is negative 3 over positive 4, and that doesn't reduce, so I'm going to leave it as negative 3/4. Okay, moving to this other guy, same basic idea holds. I'm going to start at one point and go to another one. So I'll start there and go to there. Now, again, I've gone down in this case, so it's negative 1. And then I've gone 2 to the right. Again, it's 2 to the right, so it's still positive. So I've got a negative 1 on top of a 2, negative 1/2. Okay, at this point you might be thinking, well, hey, what if you go the other way around or something like that? Well, let's do that. Let's start at this point and go to this point. Alright, so at this point I'm going to go up 1. Okay, so that's a positive 1 now, so you might think, hey, well, things are changing, but really they're not, because as I go from where I just was over to the left now, okay, notice I've gone to the left, so now this is in a negative 2 direction. So if I want to think of it this way, I've got 1 over negative 2, and I admit this is just kind of awkward, but if you think about it, I've got one positive and negative number, so either way you slice it, ultimately what we have is a negative number for our slope, and quite honestly, I like putting the negative on top, so it's really the same thing. I would not mark it wrong if you gave me 1 over negative 2, but it's just nicer to do this. For those of you with a calculator, type that in your calculator and see what happens. The calculator tells us in some way that it doesn't really like it, but I'm going to leave you to do that on your own. Well, with a lot of things, there's sometimes some unusual cases, and we've got 2 of them here, so here they are. Okay, now, again, I've got my line. It's a nice horizontal looking guy right here, so I'll just pick any 2 points. I'll pick these 2 right here. Okay, and again, slope. I just want rise over run. Now what's weird about this one is my rise, notice I don't go up or down at all. So basically my rise is 0. Okay, and in this case, since I'm going from this guy to this guy, my run is just simply 1. Okay, well, I got 0 over 1. Well, what is 0 divided by anything? Well, 0 divided by anything is 0. So what we have here is 0, slope 0. Basically, is anytime you see a horizontal line, you're going to have a slope of 0. Alright, you might have not thought that last one was all that weird. This one, I think, definitely is if you thought that last one wasn't. But here we go. Okay, now I got myself a vertical line. Okay, and again, I'll just pick any 2 points, just to be different. I'll pick the 1 right here, and I'll go all the way up to the top, skipping the middle guy. Okay, but again, rise over run. Well, this one's rise is pretty simple. I go from here all the way up to that guy, so that was a rise of positive 2. And then the trick is my run. Notice that I've already made it to my other point. So my run is how far I have to move side to side. And in this case, there is no side to side move, so my side to side is a 0. Okay, now a lot of people look at that and think 0 right away, but again, I asked you to type that in your calculator in case you don't believe me here, but dividing by 2 is what we call undefined. So anytime you have a 0 in the bottom, right there, that's something that's bad. We just can't do it. Frowny face and everything like that. But basically, for slope, it's not anything to freak out about. We just simply say, hey, that vertical line, its slope is undefined. Alright. And anytime you're going to have a 0 on the bottom, I don't even care what's on top. If I have a 0 on the bottom, I know my slope is undefined, and I call it a day from there. Now, we're not always going to be fortunate enough to have a graph already made for us, so we need to be able to get the slope based on other things, for instance, 2 points. Now, what we did before, we figured the slope was rise of a run. But, again, if you don't have that, we have to use something else, and I'll come up with that in just a second for us here. But, okay, now if you think about rise of a run, the rise, like from this first example that we did, from here to here, okay, we said the rise of that guy was 2. Okay, now if you think about the coordinates here, I've got a 1 and I've got a negative 1. And basically to get a 1 and a negative 1 to turn into 2, you got to subtract them. And maybe that isn't all that obvious to tell, but how about if we do the other step? If we go from 1 up to 3 and then across, same thing. It's still going up by 2, and if you notice, if I do a 3 and a 1, and I can subtract them and get myself a 2. Now notice those are the y coordinates because they're on the y-axis here. So the kind of rise we can get by taking the y coordinates and subtract them. The way we're going to say that is a formula sort of thing is we're going to take the y2, which just means the second y, and we're going to subtract y1, the first y coordinate, to get our rise. Okay, the run we're going to get in a similar fashion, but the run, of course, is our side-to-side move. Okay, and again, for our first one here, I went from negative 3 to 0. Okay, and our run was supposed to be 3. So again, it's going to be a subtraction, or again, from 0 to 3, same basic idea. But long and the short of it is, what I need to do then is subtract my x's. So it's going to be x2, the second x, minus x1, and the first x. And that's going to give us a nice slope formula that I do want you to have memorized. I'm sure some of you have seen that before, but for those of you who haven't, there it is. But for all of you, I need you to have that memorized. Alrighty, let's do a couple here. I want to find the slope of the line that passes through 4, 8, and 2, negative 3. Okay, well, of course I could draw a big graph and then plot those points and then do the kind of counting rise of a run that we did previously, but sometimes that takes quite a long time. And if you get to the formula, this should go a lot faster. Okay, just to write it out once, I'm going to rewrite the formula here, y2 minus y1, x2 minus x1. Okay, and additionally, be careful with the points. Some people get this mixed up, but if I have a point here, remember the first guy is always an x and the second guy is always a y. And for no real reason other than he came first, I'm going to call this guy x1 and this guy y1. Okay, likewise, the first guy is an x, the second guy is a y, and since this is the second point, I'm going to call these y2 and x2. Sorry, x2 and the y2 in the right order. Okay, and then it's just a question of plugging the right numbers in the right place. Now, I've got something minus something else, so what sometimes I like to do is kind of write the fraction bar and the two minus signs, so it looks like a big divided by sign actually, but whatever the case, and then I'm just going to put numbers in the 4 spots that I have there. And again, it's y2 minus y1. So here we go. The y2 is a negative 3, so I put him first, minus the y1, which in this case is an 8. And then my x2 is a 2, and then the x1 is a 4, and basically there you go. Now, just basically an order of operations problem right now. Just work out the numerator and denominator separately, and then reduce if you can. So I've got negative 3 minus 8, which is negative 11, and then 2 minus 4, which is a negative 2. Alright, so if that didn't reduce, I'd be done. However, notice that I have 2 negatives. 2 negatives make a positive, so at the very least I can call this 11 over 2. However, I ask myself, does this reduce? In this case, it does not, so 11 over 2 is my final answer for this one. Okay, now if I want to find the slope of the line that passes through those 2 points, again, same basic idea. There's my slope, there's my x1, there's my y1, there's my x2, there's my y2. And again, it's just a matter of plugging the right numbers in and then working it out. So there's my kind of format. So I'm going to have a negative 3. Okay, now here's a mistake people make. There's a minus sign in the formula, and then I've got this minus 1. Okay, one of them is from the formula, the other is from the number, and if there are 2, you need them both. So it is negative 3 minus negative 1. Just don't assume that if I got one here, that I don't need the one from the number. It is very important you include them both. Alright, moving on. I've got a negative 4 as my x2, and then I've got a positive 5 as my x1. And again, just work out the numbers that you have. I've got negative 3 minus negative 1. For those of you that feel better this way, take that extra step and do the leave change change and make a negative 3 plus 1. And if you want to do that in a numerator, denominator as well, you could do that. So negative 4 plus negative 5. Okay, that's a whole personal opinion sort of thing, so if you don't want that step, don't do it. But I've got negative 3 plus 1, so that's a negative 2 on top. And then negative 4 plus negative 5 is a negative 9 on the bottom. Now notice again, two negatives make a positive. And also this guy does not reduce, so there he is, 2/9. That's his slope. Alright, now the two unusual cases do show up again in the algebraic way, which is basically what we've been doing with a formula. And here it is. Okay, so I've got negative 6/2 and then 5/2. Okay, so my slope, again, fraction bar, 2 minus signs. So I've got 2 minus 2 on top, and then I've got a 5 minus negative 6 on the bottom. And just plug in the right numbers in the right spots. Okay, 2 minus 2 is 0. Yeah, that's a little bit funny. And then 5 minus negative 6 is positive 11. But, quite honestly, the second I see this, I know that 0 divided by anything is going to be 0. So really that 11 was irrelevant. That could have been a 2, it could have been an 8, it could have been a negative 458. Doesn't matter. 0's on top, that whole thing's going to be a 0. Okay, now if we do it with the other example here. Okay, well you probably already figured out what it's going to be, but just to show you the work here. Okay, I'm going to do y2 minus y1, so in this case it's 4 minus 7. And then x2 minus x1 is, well, sort of coincidentally, but not really, 9 minus 9. Alright, so then I do my subtractions. 4 minus 7 gives me a negative 3, 9 minus 9 gives a 0. And again, just like when we're doing with the graph, that 0 on the bottom is bad news, we can't do it, but again, it's nothing to freak out about. Because we have a 0 on the bottom, it just means that whole guy is undefined. Okay, now if you remember graphically, that's 0 slope, so basically this guy is a horizontal line, undefined, this guy's a vertical line. Alright, now we made it to the try these, so just a few seconds for you to take a look at those. Alright, give this a shot, and I'll see you in class.